So, analysis services has two different models. One is multidimensional model, the other one is tabular model. Multidimensional model was the pre-existing, that means it was existing since 2000, I guess, or 2005. Tabular model was introduced in 2008, if I am not correct, or maybe 2012. Okay, but so why do we have multidimensional and tabular models? The reason for tabular model is let's go back to multidimensional model. The problem or the issue with multidimensional model is multidimensional models are complex. As we saw, you need to do lot of stuff to build a multidimensional model. You need to have a relational proper dimensional model, and you need to build the dimensions, facts, and all those stuff. So, to build a multidimensional model, you need a developer or engineering team's effort. That means engineering teams need to be involved in building the multidimensional model. So, Microsoft came up with tabular model where a power user who is not a developer can build a model quickly to analyze the data. So, let us say if I need to quickly analyze orders data for last year, instead of me building the whole multidimensional model, big cube, and deploying all those things, I can quickly go and build a tabular model and do the analysis on tabular model. So, the main intention between tabular main intention in coming up with tabular model is the ease of use. So, you can easily create the tabular model, and this is the second flavor within analysis services, and we have multidimensional model and tabular model. So, when we are installing analysis services into our server or machine, we cannot have both multidimensional and tabular model on same instance. Multidimensional model and tabular models cannot exist on the same SQL Server instance. So, you need to have a different instance where tabular model can run. So, that is why when we install SQL Server, we first install multidimensional model, and then we install a tabular model with a different instance name. And looking at the components in a tabular model versus multidimensional model, as I was saying earlier, multidimensional model is complex to build compared to the tabular model. So, in tabular model, we do not have all the complexities that involved in the multidimensional model. And if you look at the components within a tabular model compared to the multidimensional model, you see data sources, you see models, and you see roles. Okay. So, you do not see dimensions, you do not see data source views, you do not see cubes, you do not see mining structures, you do not see assemblies. Okay. All you see is data sources, models, and roles. But when we are browsing the cube or when we are browsing the tabular model, the user experience will be same as multidimensional model. That means, when I am browsing a model in the tabular model instance, I see the similar UI as multidimensional cube. That means, I see measures, I see dimensions, I see members, I see hierarchies. So, the user experience will be more or less same with tabular model versus multidimensional model. But while building the tabular model, you do not need to worry about all other stuff that we need to worry in the multidimensional model, like data source views, cubes, dimensions, and all. Okay. So, these are the three components available within a tabular model. And tabular model is in-memory database in analysis services. That means, once we build a tabular model and deploy it to the server, process it, the database will be in memory. The model will be in memory of analysis services. So, since it gets into the memory of analysis services, it will be very fast to query compared to multidimensional model. In case of multidimensional model, what happens when we process the cube, the data gets stored in the analysis services server in the form of files, and whenever user access the queries or whenever users access a part of the cube, analysis services caches that query. That means whatever the result set is getting out of that query is cached. So, next time when different user goes and runs the same query, analysis services knows that, oh, I ran this query already, so it gives the pre-existing cached output. Whereas in case of tabular model, the complete model is in the memory. So, it is a in memory operation. So, that is why the performance will be faster compared to multidimensional model. And tabular model uses a VertiPack compression algorithms. So, VertiPack VertiPack engine, it is called VertiPack engine, which is introduced as part of Power BI and Power Pivot efforts. So, VertiPack engine is responsible for compressing the data. That means it compresses the data so that it retrieval is faster. And tools like Power BI, Excel, Power Pivot use the same VertiPack algorithms. So, the underlying engine for all these tools like Power BI, Power Pivot, Power View and all is VertiPack. And it is easy to build. As I was saying, the main purpose of coming up with tabular model is easy to build. That means you do not need engineering effort and more development effort to build a model. You can, a power user can quickly go and write queries and build the model. But that is for basic analysis though. It is not that you can just quickly build a tabular model however complex you want. No. If you want to do the basic analysis, you do not need a dimensional model. You can take the raw data, raw tables, and you can write your own query and quickly build the model. Okay. So, when you said easy to build, it is for basic analysis purposes. And there are some cons within the tabular model. So, at some scenarios you cannot use, or it is not recommended to use tabular model. So, one of this is when you have a dimensional model. That means, when you built a proper dimensional model as a star schema, like you have specific dimension tables, fact tables, and you properly arranged the data using dimensional modeling, and it has complex relationships. That means, if you want to get analytical data, that means if you want to see, let us say if I want to get orders count by last year for a by last year by product. Okay. So, if I want to do that, when we have a dimensional model, what happens? I need to make multiple joins to the tables. I need to join the fact table, I need to join dim date, I need to join dim product to get all this information. So, if you have such kind of a complex dimensional model, it is not recommended using tabular model, because we need to make multiple joins. Tabular model is very useful when you have a flat data in the sense, let us say your source is giving a flat file, and that flat file includes all the information like date, date ID, date per month, year, and orders count, product ID, product name, everything in a flat structure. That means you do not have proper different tables or anything. One table is containing all the columns, all the data needed, including dimensional data and fact data. So, in those scenarios, tabular model is very effective. So, in those scenarios multidimensional model is not so effective. If you want multidimensional model to be effective, you need to have proper dimensional model. That means you need to have proper star schema, dimension tables, fact tables. If you have that kind of a model, logical model or physical model instead, you get a better performance with multidimensional. Whereas in case of tabular model, if you have a flat column structure, flat tables with all the dimension and fact data in it, it will be performing better because of the VertiPack engine. And analysis services multidimensional model provides a support for write back. That means not only the multidimensional models are used to read the data or to browse the data, you can actually write back to the cube. Write back to the cube means you can write the data back to the cube, and thereby you can write the data back to the SQL server, underlying database system. So, multidimensional model has that flexibility. You can write back to the cube and thereby writing back to the underlying SQL. Whereas in tabular model we do not have that feature. There is no support for writing back. And when you want to do complex calculations, it becomes difficult in tabular model, and again it depends on your expertise. So, tabular model uses DAX. DAX is similar to Excel expressions. So, if you are very good at Excel calculations and Excel expressions, DAX will be easier. But in general, if you want to do complex calculations, tabular model may become difficult to use or to create, to build. And scoping and named set concepts are not available within tabular model. The main thing is complex calculations. If you want to do complex calculations like let us say year-over-year analysis or maybe allocations, those kind of calculations, tabular model will be difficult to do. That means it will become complex to write the DAX expressions, and it is again these cons are subjected to change. That is important here, subjected to change in the sense Microsoft is investing so much effort into tabular models. So, all these constraints what we are talking is for now. That means these constraints may go away in future releases. Once tabular model or once they come up with calculations, proper calculations to do complex calculations, proper functions to do complex calculations, even this complex calculation con may go away. So, whatever the cons we are talking here are for now. Okay, this may not be cons or this may not be limitations in future releases. In tabular model, as I was saying, we have three components: data sources, model and roles. A model is an abstraction over data sources that provide control of the data structure. That means a model is basically a container of your data. The model contains your data that is coming from the data source. It is basically abstraction, and model represents the logical schema. That means when it contains the data, it represents the logical schema built over one or more data sources. You can connect to similar to multidimensional model. In tabular model as well, you can connect to multiple sources. Models can contain tables, relationships and calculated columns. This you can have tables and you can have logical relationship between the tables, and you can have calculated columns within the model. And models are not visible to the client applications, but its tables and columns are visible. So, when we are browsing the tabular model, a user will not see the model per se. There will not be anything like a model. As I was saying, from users experience perspective point of view, the tabular model behaves the same as multidimensional model. Okay. So in tabular model you won't see a model per se in the browser when you are browsing the tabular model. Models are the only data source that tabular model can manage. Okay, that means tabular model can contain only models that contain actual data. So basic elements in a model is tables, logical relationships, calculated columns, calculated measures. Okay, so these are the basic elements in the model, and you can have hierarchies, you can have KPIs, you can have perspectives. So let's say we want to browse a tabular model. Okay, so if you want to browse a tabular model, you will be connecting to a tabular model instance. So I can go ahead, connect analysis services. I need to pick analysis services because tabular model is a flavor of analysis services. Click on analysis services and I provide my server name and the instance where the tabular model is installed. Okay, in my case tabular is my instance name. Connect, and when I connect it shows the databases. So these are all tabular models. Okay, so I have 4 different models here, projects deployed. So if I want to browse the model, I will be going right click and I will say browse. So when you look at this browser, you see the same browser as multidimensional model. So when you are browsing a cube in multidimensional model, you see the same structure, but the only difference here is it says it's a model, but you can rename this as well. Okay. So as I was saying, from user experience point of view, whether you browse this through Management Studio or from Excel, the behavior or the experience will be same as multidimensional model. You will have measures, you will have dimensions, you will have hierarchies. Okay, so that doesn't change. See this one, if you look, there is no difference between multidimensional model and tabular model. Everything looks same. So internet sales, and let's say if I want to take a calendar hierarchy, I see this data. Similarly, let's say if I want to connect through Excel, so I open Excel and I go to data, from other sources, from analysis services, and I will provide my instance name, and I have the model where I can pick internet operations or whichever I want, or I will pick a model. Next, finish. So I see the fields here, the pivot here, and I can say internet orders. Let's say I want to see internet total sales by calendar hierarchy from the date dimension, date calendar hierarchy. So if you look at this pivot, I don't see any difference between multidimensional model and tabular model. So the experience from user point of view, it will be same whether you build it using multidimensional model or tabular model. So that's the main reason why you have a second flavor within analysis services. So we are building a similar cube like a multidimensional model with less effort. Okay, that is the main advantage with tabular model. And as I was saying, the basic elements you will see in the model is tables, logical relationships, calculated columns and calculated measures. Then you can build KPIs, you can build perspectives and hierarchies. So we saw already hierarchies, and we can have calculated measures like this, and we can have calculated columns as well. And if you expand the model here in the database side, you don't see cubes, you don't see dimensions and all like multidimensional model. What you see here is connections, which are the data sources, and the tables and roles. Roles are for security, where you define a role and provide access to a specific user, and then the tables. So all these dimensions what we see here are all tables. In tabular model we don't have a concept of dimensions while building the model. These are all tables. All we have is tables in tabular model. The table could be used for a measure, or that table could be used for a dimension. So it does not matter. All the elements that we see in the model is tables. Okay. So connections is the data source to which SQL server you are connecting, or this model is connecting, and the tables are, as I was saying, the tables that contains the actual content or data. Then the roles are security purposes. Okay. So that's what you see in the tabular model. And in a tabular model, a table is the basic element in the model. That means that's the only element you will see in the tabular model. A table is based on a set of columns which are based on tables defined in the data source or queries to be run against the data source. That means a table can be just the table defined in the source. That means you are accessing the table as is, or a table could be a query that run against the data source. So several tables can be retrieved at the same time, but not several queries. Basic changes can be done before relational tables are imported. That means you can filter out the data. For example, if you want to get a subset of data into the model, you can filter out the data because you have the option to write the query. Okay. So we will see how we can basically create a model first in place, so that we can move forward on those concepts. So this is my Visual Studio. I can go right click onto my solution, click add new project, and in the new project wizard I will go to business intelligence, and then I will click on analysis services. I go to analysis services tabular project. Okay. So analysis services tabular project, this is the one I need to use to create a tabular project. So I will leave it as a tabular project, click OK. So it is creating an empty tabular project for us. So before creating a project, it is asking for a connection. So to which tabular instance should it connect? So I need to specify the server name and the instance name, and then there is an option for compatibility level. Compatibility level means what is the SQL Server version we are running. Based on that compatibility level, a tabular model will be built. So for us, since I am using SQL 2016, I pick SQL 2016. Click OK. So it created a tabular model for me. a project for tabular model. So, if you look at this model here project, all you see is references and model, nothing else. Okay. Like in multidimensional, when we are creating a new project, you will see all the options for cubes, dimensions, measures and all, roles, all that stuff. Whereas in tabular model, all you see is model.bib. And this is the left side pane is where we are going to build the model, and we build the model here. We import the tables and we can create hierarchies, we can do whatever we want to build the model here. Okay. So, these are the two areas we will be using in a tabular project or while building a tabular model. And we will try to import some tables. So, as it was saying here, tables can be imported directly that are defined from the data source, or we can run the queries. So, if I need to import a table, first I need to create a connection to the source server. Source nothing but our SQL server. So, to connect to the source or to create a connection to the source SQL server, I go to the model here, click on the model, and then I will say import from data source or existing connections. If we already have a connection, I can go to existing connections and select the tables from that connection. But since I do not have any connection, I need to create the connection for now. So, I will say import from the data source, and what is my source? SQL server. Click next, and my server name, that is my SQL server name, and the database name I want to access, AdventureWorks is my database. Click next. I want to use service account to connect to my source. Click next. Here you have two options, either you pick that or tables as is, tables or views as is from the source to import, or write a query to specify the data. That means you can write a query to get a subset of the data or the required columns from a table, or you can import the data or table as is. So, let us say how to import it. I will select from the list of tables, and it will load the list of the tables for me. And for my exercise, I want to have some queries here, but so I want to have dim customer for my exercise. Okay. So, for dim customer, I will just pick the complete table instead of writing the query. So, I will go here and I will say dim customer, and similarly I need dim product category, dim product subcategory. So, I want to build a product dimension, and for dim customer for customer dimension. Okay, finish. So, if you look at these messages here, it says importing data, importing, retrieving. So, why is it saying importing and retrieving? When we are building a tabular model, the analysis services or this project pulls the actual data into the model. So, when we have a huge volume of data, we should be careful. That means here its dim customer has 18,000 records, right. If let us say there were a billion records in a fact table, then it will try to load all the billion rows. Okay. So, we need to be careful when you are building the model. When we are building the model, do not get all the billion rows into the model. Instead, get a subset of data and then add partitions to get the remaining data. Okay. Close. So, here you can see the data, actual data that is being loaded into the model. So we imported 4 tables: dim customer, dim product category, and dim subcategory. Okay. So this is the data structure. That means you can see column structure, you can see data here. Similarly, if you want to see logical relation, you can click on this little button here. So you see this logical relationship button here, you click on that. Oops. Okay, so my Visual Studio crashed, so I lost all the tables information. So I will go ahead and load the tables again. Let's see if I still have the connection. No, I don't have. So I will say import from data source, SQL Server, click next, my server name, AdventureWorks, click next, service account, next, select from a list of tables. I will select dim customer, I will select dim product category, product subcategory, click finish. So it is loading the data, preparing to importing the data for all the tables we defined. Close. I will save it. Now as I was saying, there is a logical relationship diagram button here. So we can use this one to define the relationships or to check the relationship between objects. So I click on this one. Now I see the same objects in a form of diagram, logical model. Okay, here it shows the relationships between the objects or the tables. Okay, dim customer has no relationship with the product tables, that's why it doesn't show any relationships. I see relationship between dim product subcategory, and product category. Okay, now let's say I want to use a query to get the data. So I already have a query that gets a dim date information from the table. So I take this query. So now I want to get the data using the query. So there are two options. One is click on the model and again you say import from the data source, and you proceed with the same steps that we did earlier. That means you specify the server name and move on. But what happens if you do follow this approach is there will be two connections created. Though we are using the same server, since we are connecting a data source, it will try to, or it will create two connections. So that approach you need to follow if your source data is in two different servers. Okay, let's say your source data dimension data is one server and fact data is another server, or maybe one data set is one server, other data set is another source server. You can use two connections, but for our case all the data exists in one database. That means all I need to have is one connection source, one data source. So I don't want to go in this route, connect to a data source route. Instead what I will do, go to click on the model and select existing connections. Okay, so this is my existing connection. I want to use this connection to import new data. Okay, I select on this connection and I will say open. Click open. Now you see again two options. One is select from a list of tables from the source, or write a query. Write a query is useful especially when you are joining multiple tables, but in our case I want to use the query to just get the data from dim date, and I will call this query as dim date. Okay, finish. Now it is again importing the data. Close. I will save this model. Now if I go back to my diagram, I see dim date but without any relationship. Now similarly I want to import fact data, which is my fact internet sales. So I will go to the model again, existing connections, open existing connection, write a query, enter the query, and I will say fact internet sales. Close. Okay. So now I have 1, 2, 3, 4, 5, 6 tables defined. Now I will go to the logical relationship and I want to try to build the relationship between these fact tables and dimension tables. So far only this dimension tables, 3 dimension tables are related with logical relationship, but now I got all the other 3 tables. I want to build the relation. So my order date key is mapped to dim date. Okay. Similarly my customer key is mapped to the dim customer key, and my fact internet sales product key is mapped to dim product key. Okay. So that is my logical relationship between the tables. Okay. So now I am done with creating or importing the tables that are needed for my model. Okay. So I will try to deploy this onto the server and see how it looks. So before deploying I will go to the properties of the project. I will make sure that the server name is listed correctly and the database name is tabular project. I will just add class, that is the name of my tabular project database that I am going to deploy, and click OK. Save it, right click and say deploy. So this is when the tabular model will gets deployed to the server. So you see the model gets deploy metadata first step, and then it tries to process all the dimensions similar to multidimensional model. Okay. So it is processing all the dimensional data, or you can say it is processing all the tables. In a tabular model it is all tables, there is nothing like dimensions and facts. As a logical model we can call them dimensions and facts, but in the tabular model these are all tables. Click close. Now I will go to my server, refresh, and I see a tabular project underscore class. That is the one I just deployed. If I right click and if I expand this one, I just see connections, tables. Tables are my 6 tables that I imported, and there are no roles yet, and my connection. So I can say right click and browse to browse this model. So when I am browsing the model, I see the tables, all the 6 tables listed as dimensions. Okay. And there are no measures here. Measures are empty because I haven't defined any column as a measure yet. That is why all the tables are treated as dimensions here. Okay. So this is how we deploy a tabular model to the analysis services server, and this is how we import the tables into the project while building the model. And we saw how the logical relationships can be built. A logical relationship can be created in the model, can define a logical between the tables from the same data source or different data source. So once we import the data into the model, it does not matter whether that particular table is coming from whether those tables are coming from same source or different sources. As I was saying, if one data set is on one server and other data set is on another server, you can still import the data into the model and then build the logical relationship between those tables. So, once you build the data, import the data or import the tables into the model, you can build the relationships. Relationships between columns in two different tables can be created, but relationship between two columns in same table cannot be built. That means parent child relationship is not possible. Again, this is for now. They may be changing. That means there may be improvements which can allow parent child relationships. And we have calculated columns. So far, when I built this model, I haven't defined any column as a measure, right? That's why I see measures as empty, because in this model all I did was importing the tables. I haven't defined any column as a measure. So, you can use calculated columns to define a column as a measure, or you can create a calculated column to create a new column. Okay. So, I want to add a calculated column to dim date, or I want to add a new column that is getting derived as a calculation within the model. So, that new column I want to build is English string for the quarter, which is English quarter name, and the format should look like this one. So, when I write a SQL query, the query will look like this one, that returns me a string format of quarter, like English string Q1 and the year name. Okay. So, this I want to build this one within the model. So, I can say add column my column name is quarter description. I will just say quarter description. So, I am creating a new column here, and what is my expression for the column? I put the expressions here. So, it is similar to Excel expressions. Okay. So, the expression would be Q So, this is the function to derive quarter description. So, what I was struggling was I have put plus. So, plus is not used in DAX for concatenation, it is ampersand. Concatenation is done using ampersand symbol, not using plus. Okay. So, we derived this expression which returns a string format, same as the one we derived in SQL, and we created a calculated column for this one, and I will save this one and deploy it to the server. Deploy.